Siang.
Yeah.
I just learned this word before coming to here. Really appreciate the organizers IDNIC to give me the opportunity to come here and talk to you, to share some experience and also learn something from you. At the back, can you hear me?
Yes.
And is my accent, like English, is okay?
Okay.
I can learn Bahasa, but I need like 5 years. So it will be too late. So today I'm gonna talk, I'm gonna speak in English. With me, I'm very, very happy that we have two experienced engineers with us. Arif, do you wanna introduce and then APNIC you also? Yeah.
Okay. Oke, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Sudah pernah ada yang jumpa dengan saya sebelumnya di IPv6 juga? Belum atau baru? Ada yang baru, ada yang
Baru
ya? Oke, kan ini kita mendatangkan training langsung dari APNIC di trainers Mr. Awal, dan mungkin ya agak sedikit bahasa Inggris ya. Nanti mungkin akan kalau ada apa-apa mungkin saya bantu terjemahkan gitu ya. Atau kalau ada pertanyaan nanti saya juga akan bantu translate kan. Atau ada Google Translate kan di situ. Oke. Yes. Berikutnya Mas Api, oke silakan.
Langsung aja ya. Jadi kalau karena ini baru ya. Kemarin kita kapan isi? Kita bulan Oktober ya?
Terakhir enggak di Batam ya?
Oh iya, di Batam.
Di Lampung ya? Oh iya.
Iya.
Jangan-jangan yang di Lampung juga ikut ya kemarin?
Enggak.
Kejauhan.
Jauhan.
Oke, pengalaman dulu Mas. Mas Arif Dilaksanakan, nama saya Ahmad Rafiuddin. Biasa dipanggilnya Aping ya. Atau mungkin kalau yang kesulitan panggil Aping ya bisa panggil Mas Ahmad atau Raffi sama aja. Aping sama aja.
Oke, kita mungkin
langsung aja ya,
langsung aja karena agak besar tadi ya.
Thank you so much. We will have a very quick workshop today, and the speed will be so. Who is here who has previously took a roller coaster ride? Have you done that?
Ya.
This is today again we are gonna do a roller coaster ride because this is gonna be very, very quick workshop. So I need all of your attention.
Okay.
And if sometimes I go crazy and speed up my voice, like very quickly speaking, just let me know that this is crazy. So yeah, I'll slow me down. But today contents are very, very large, but we try to fit in the time. Okay. So very quickly read 10. Yeah. So yeah, there will be a prayer and lunch break in between our two sessions. I'll come to that later. It's not working at the moment, but yeah, the SSID is there, but the internet is not there. So for the lab, you have to log in to this SSID. I'll come to that later. No need to log in now because you'll not get internet. Yeah, quickly, first session, I'll try to cover the theory very quickly because it will focus on the lab more than the theory. Theory, you can download the presentations and can spend time. Okay. I'll show you how to go to the web page and then download the PDFs. I'll show you later. This is the lab that we are going to start, and I'll talk about it once we do the lab. This lab is very busy lab. You can see so many information, but I'll explain it when it comes to this. This is a mailing list we have. If you have any question you face when you run a network and you want some help, you can send an email to this list. There are several engineers and trainers in the group. They will get the email and then they will try to respond if they know the answer. This is the academy. You will see how we do. We have several virtual labs. You can practice. if you have an account to our academic portal, but that's a free account. Anybody can join and can test the labs by themselves and can also join our trainings. Have you heard about APRICOT? APRICOT is one of the largest technical conference in this area, in this region, like Asia Pacific. And APNIC jointly organized its own conference as well with APNIC. So the next one, which is APRICOT 2024, along with APNIC 57 conference, is going to happen in Bangkok, not very far from here. So if you are interested to join, there's a nice conference every year that occurs in February to March. So it's like 10 or 12 days or something, so you can see the dates. Just check the website, apricot.net, and you get the information. This is like a marketing slide, no need. Okay, so let's jump to the presentations. I'll share the presentations soon, but let me, because we don't have enough time today, quickly let's cover some contents. And if there is some sentence or some information that needs to be translated, please interrupt me. And then, because there is some important message which may need to be translated. Okay, so the first presentation that I have today is about the address, how it looks like, IPv6 address. And then the second presentation is how you plan with the address you have, and then configure in your real network, right? So this is a comparison, and this is like a common slide. You will find this slide in many places. And the summary is IPv4 is a little bit complicated. The header is having more information. IPv6 is simpler, as you can see in a first look. This one is like clean, looks like a clean, much smaller number of headers, but actually it's bigger. So the size is double than IPv4, but it's simpler. The size is bigger because the address itself is bigger. As you can see, previously the source address was like 32-bit, destination address 32-bit, but now it's 128-bit each. So it's bigger. But the more header information, the more time it takes for a device to process that. So in that sense, IPv6 header processing is a little bit better compared to the IPv4 header. So in IPv6, we have something called extension header. I'm not covering all the fields. You see the version, the type of service matched with the traffic class. So the color, which is gray, is same as the IPv4. It didn't change. Only the size changed. The color with the green, the function remains same, the name changed. So the type of service is same as the traffic class. Type of service, that means service classification, is actually classification of type or traffic. So that's same, but the name changed. The time to leave became hop limit. So the name changed and the position changed, but the function remains same. What is the time to leave of a packet? What is the time to leave value of a packet? The TTL.
Yeah. Time to leave.
What's the number?
Number for
TTL.
routing, for untuk penjagaan routing loop.
But what's the number when the packet starts? What the
Oh,
value
1
it
sampai
takes?
25 nih. 1 sampai 2. Ya,
255. That's the correct answer. I have gifts if you answer or if you ask questions. Both cases you are gonna get gifts.
Belum dimulai.
I have several different types. I'm gonna save some gifts, but this is a mini screwdriver.
Thank you very much.
You can actually open your laptop. but what happens is I have a friend who is not a network engineer, so he had a laptop which was having some problems. So he thought, why paying the mechanics? Instead, let me see the YouTube video. And then he saw the YouTube video and opened the laptop. And then after that, he cannot bring it back. So don't open. It can open, but if you know how to fix, then open it. Otherwise, yeah. So it has a 255 of value, same as the hop limit. The protocol is the upper layer protocol. IP is layer. Which layer? IP is which layer? Layer 3. Layer 3. I need your interaction as well. Just otherwise you are gonna be sleeping. Okay, you need to keep yourself awake.
Okay.
So IP is layer 3. The layer 3 header needs to know what is the upper layer header, upper layer information. Is it a TCP or a UDP or ICMP or things like that? So this protocol is same as the next header, but next header actually contains a little bit extra information sometimes. I'll explain, and that's the next slide I'm coming. What else? Payload length and total length. Total length means header plus payload, means the data. Header plus data is the total length. So in your IPv4 header, you have information like how much information you are getting, including the header and payload. But for IPv6, you don't need to know about the header, you just need to know about the payload because the header is fixed, 40 bytes, no change. So anything after 40 bytes is the payload. But for IPv4, because there are options and padding, it's variable, it's not fixed. It's minimum 20 byte, but not fixed. And that's a big problem as well. When you compute the processors, the CPU, it needs to apply the variable logic, right? You don't know what is the value. That's a problem for the processors. Yeah. Anyway, I'm not going to go very deep into this, but this one only covers how much value you have after the header. But this one covers everything, okay? So these are some of the changes. Flow level is a new addition, so the blue color is a new addition. And that's actually identify every single flow with a unique number. So next header is an extension of the original header. As you can see here, the next header is an extension. If I need more header, IPv4 had the option values and other variable parameters. But IPv6 doesn't have any variable header, it's a fixed. So how can I add more header? That's why there is an extension header, and how it works? Like this. So this is the original 40 byte, and I am expecting either upper TCP or UDP, right? Upper layer header. But sometimes I don't want to go immediately to the upper layer header. I may need to do some IPsec or some tunneling header. Why should I put those header? Because it's fixed. I cannot create a new field. What I can do is I can point this with a number, and the computer or the device will understand this is not the end. The next information is not data, still header. So you are taking the payload space to add more information, and all device will understand that because you use a pointer. You use a value that doesn't indicate that that's the upper layer header, right? So there are some predefined standard values for the additional functionalities. So let's say 0 means hop by hop, means every hop, every layer 3 device you pass, they will read that message, information. So I'm saying that the next value is not upper layer header. How computer understand it's upper layer header? Because for TCP it's 6, for UDP it's 17. If you don't get these two information, that's not upper layer header. That's an additional header. That's how computer will understand. The servers, the routers, they will understand. So let's say I put 0, that means this is not the actual data yet. It's hop by hop header. And on the hop by hop header, I said the next header is 43. That means I want it to be routing and then the next header is 44, 40, and then finally I got next header 6. That's an upper layer header. That's when computer understand, okay, no more header. Now the payload starts, okay? So you are like, for example, I was coming to this venue, I went to the elevator, that's the other side. So I couldn't get there, and then I asked somebody, he showed me another person, I asked, and then finally somebody bring me to this room. It's like this additional information and reaching to more functionalities without changing the protocol. You can add more functionality without changing the protocol. Just a number, new information. Something like this. Now, the fragmentation. What is fragmentation? What is a fragment?
Tidak tahu fragment.
Penyusutan.
Penyusunan.
Yeah, try. Fragment. What is a fragment?
Penyusutan sebuah paket header.
Apa? Ada yang tahu fragment? Coba apa? Bahasa Inggris sama masih saya tidak dapat ya.
Yeah, no problem if you are shy or I'm not so sure. Are you shy? No. Remember, there are gifts. If you are shy, just remember there are gifts if you answer. Okay, so if you are traveling from here to Jakarta and you have so many things to take, but you have the baggage that doesn't fit, you need another baggage, right?
Yes.
But that has to go to the same place. And once you open, you can get all your information, all your things. You cannot send everything in the same bag. That's why you had to bring 2 bags. That's fragmentation. If you have many data to send to another computer, and one packet is roughly 1500 bytes, you can extend that, and I'm not going to go deep into it, but let's say 1500 bytes, but you have, let's say, 5000 bytes. You need now 3 packets. But that has to go to the same place, and the same person needs to open all the 3 packets. If one is dropped in the middle, then there will be a retransmission, right? Those are the technical things. I'm not going to go very deep into it, but that's the idea of fragmentation. In IPv6, this fragmentation is done only at the source, not at in the middle, okay? So if you can see this, so I'm trying to draw it bigger. If you cannot see, you need to go and buy some glasses or something because there is no space right here. So yeah, so let's say, what was I saying? Fragmentation, right? Okay, yeah. So let's say this is a router, and then in the middle I have another router, and then finally here, okay? Can we flip it like this, like a horizontally? I think there is a way to do it. Yeah. Or not? It's screwed. So no. I think it's screwed up. So no problem. Anyway, yeah. So let's say this is router 1, router 2, and router 3. Okay. In IPv4, what happens is, if you send a packet, the packet will go to the first router. It will see whether the packet size is enough to send through this link. If not, it will fragment it. Yeah. It will come to this router. This router will wait until all the fragments come to this router. It will assemble it again and will check whether it's enough to send through this link. So every single hop, it will check whether fragmentation is needed or not. But in IPv6, it's not like that. In IPv6, this router will check all the way and find an optimum fragment size so that no one in the middle need to check this anymore. It's like a seamless pass to the destination. No need to do something in the middle. Of course, if you are sending many packets, in the middle, if this network engineer changes the size, it needs to recalculate again. That's okay, but that's a very simple ICMP packet. So it's not like very long time, it's gonna wait and things like that. It's very fast, super fast, okay? That's an improvement. because no one in the middle needs to do this. That means every single router previously was taking the job, now they don't need it, right? So how it done the fragmentation? It's going to use something called path MTU discovery or PMTUD. That means the discovery of the MTU which is optimum for the whole path. And that's an ICMP packet. And you know ICMP is very fast, right? Ping packet. It's not really like a very, very heavy packet. It's simple packet and that's why it's very fast. And how it works? Let's say I want to send an IPv6 packet from host 1 to host 2. What is need to check? It needs to check whether I have enough bandwidth, or enough MTU to send the whole packet. If not, because this is a bigger packet compared to my half MTU, what I need to do, I need to divide the packet because it's not small, it's bigger, but it's 1500 from here, for example, right? So it needs to think that I need to segment the packets or fragment the packets. So it actually created 3 packets, just splitting the packets from the middle and then split it into 3 packets. Now it needs to pass. So let's say it's sending the packet. So first packet will have IPv6 header and then a fragment header. Because the destination needs to know that this is not the only packet, you need to wait until the fragments are done. All fragments you receive, then open it. Okay? So there's a fragment header. This one also have similar thing and thing. So these 3 packets goes to the destination, and once it received to the destination, it's gonna assemble. So there is some animation which is not working here, but anyway, so it's gonna assemble back to the original packet. No one in the middle needs to do that, okay? Now how it's done? So let's say packet 1, 2, 3 that goes this way, and then finally this host 2 receives all these 3 packets, and then it's actually reassembled the whole thing into one single packet. Okay. Now this is how the path MTU discovery works. How you will understand that this is the optimum size. How you will understand. And that's a ICMP packet, and the theory here is covered in this example. So that's why I'm not going to go with the language here. So let's see how it works. So I have my computer can only detect its own MTU. It cannot detect this one or this one because it doesn't have a direct connection. So only the cable connected to the device, it will only understand the MTU. So that's why if you go to the router, you will see only MTU of your interfaces, not your neighbor router interfaces, right? Because that's a layer 2 kind of information you get from your interface. So this host can pass 1500 max in one packet, not more than that, because that's the highest MTU. So it will first break its whole packet. So it needs to send 2000 bytes, but the MTU is 1500. So it needs to fragment it into 2 packets. So the first packet, it's gonna create with MTU of 1500, okay, because that's the maximum. It passes it to router 1. Router 1 checks. Router 1 finds, okay, my MTU. So this is now fragmented, and that's why you have a fragment header, right? And this fragment first comes to the router 1. Router 1 checks the MTU. It has an MTU again towards the second router, which is 1500, so it's fine with it, no problem. It will pass it to router 2. Router 2 will see, okay, my MTU is a little bit smaller, I cannot handle this packet, okay? So this is like a longer, like a bigger size. What it's gonna do, it's gonna drop the packet. This router will drop the packet and send a reply to the original host saying that this packet is too big for me. That's an ICMP reply. It's called the packet too big. This packet, once received by the host, it will also know what is the maximum it can handle. So it will reply saying that I cannot handle 1500, but I can take up to 1300. If you want to send this, please fragment it with 1300, I'm fine to carry. So this message comes to the host, it drops the packet and sends the error message, packet size too big, and say that my maximum is 1300 that I mentioned already. So it will come to this host, and host will recreate the fragments with the 1300 size. So now this one is, so the packet, it type is packet to big, and it says my maximum MTU. So this is a Wireshark capture. You know the packet capture?
Yeah.
And you can read the headers and information. So this is a reply coming from router 2. It will send to the host and saying that my max is 1300, and the packet type is an ICMP packet. As you can see, this is an ICMP 6, and the type is packet to big. And now the host will understand, okay, somebody in the middle cannot pass the packet, and it can only carry up to 1300, so I need to recreate it. Now this time it recreates it with 1300, even though its MTU is 1500, but not the whole path. That's why it's now gonna recreate it, and this packet will go router 1, pass it, router 2, pass it, router 3, pass it, and then finally it goes to the destination. And that's how this check happens very fast. And the benefit you get that every single router doesn't need to fragment like this in IPv4. IPv4, every router has to do that, right? And it is very complicated. And that's why your internet doesn't work if you don't optimize your MTU sometimes, right? MTU is a big challenge for network engineers. Sometimes you have to skip your lunch to fix MTU problems, right? They're very, very painful task. Any questions? Yes.
So what is the interval of this PMTUD protocol? Does it send the PMTUD packet every time we send the packet, or how does this PMTUD work? I mean, like there is from router 2 to router 3, there is a 1300 MTU, right? But one day we change the MTU to 1500. Does the router know that we already changed it, or how does this PMTUD work?
Thank you. Good question. Yeah. Thanks so much. That's a good question. So the question is, how frequently the router will check the MTU? This is not a frequent checking. It's not a regular routing checking. Only it will be checked if you send a packet, right? And the router will cache the reply about somebody in the middle saying that packet to be. It will cache the message, and it will keep it as its maximum MTU. So it happens only for the first packet of the whole session. Only the first packet, and then it catches the information, it keep it in its memory, and subsequent all packets just follow this process. Now let's say I am a network engineer in the middle somewhere, I manage a network, and I change my MTU, right? And that's why, and the packet will drop, and the half MTUD message go to the source again, and the source will immediately change its cache with the new information, and then start the next subsequent flows. So it's not gonna check every 5 minutes or every 10 minutes, because it will not check until it needs to send something. So yeah, that's a good question. That's the answer? Yeah, thank you so much. Any other questions? Remember, if you, yeah, go ahead. Just a friendly reminder, if you ask questions, I have some, gifts.
Does the MTU cache, does the MTU is cached per IP address or the device interface link?
It will just cache the information came from the router which cannot pass it anymore. It will tell the router how much it can pass, and then it will come to the source and it will store the information for that destination. For that destination.
Jadi hanya untuk destinasi itu saja. Per link, per pack ya. That's information only in maybe a destination.
Yeah,
B destination.
for one destination, yeah. And the next
Not all
destination can have a different one. Other destination can have different one, things like that. But remember how frequently you reduce the number. You don't usually change to less than 1400. You don't usually do 1200. You don't usually do 1300. You usually do from 1400 to 1500, or sorry, jumbo frame you enable for 9000 something. So usually network engineers nowadays just put 9000 or 9012 or 9010, something like this, just to avoid any confusion, right? So when you reduce, then think about it. Don't reduce much. Reduce it up to, like, if you are running MPLS, if you are running a couple of extra MPLS headers, then you might need to reduce it to adjust the TCP MSS values. But usually, for every destination, your router won't send the packet, it will cache the information.
Okay, it's clear. Thank you.
Thank you. It's a pen from APNIC. I hope that has some ink inside. It doesn't have any ink, and then we'll try to write. It's not gonna work, right? Okay, so can we go to the next? And please take food. We don't have any break for this. You have to take it. Don't feel shy because I'm looking at you. Don't worry about it. Okay, now this is how IPv6 is formatted, how IPv6 address looks like. And all of us probably already have seen that, but let's take a quick refresher for everybody. By the way, if you have questions and you are feeling shy to ask in English, you can ask Bahasa as well. So please don't stop you from asking question. It should be more you talking than me talking. Okay? It will be very interesting if all of you can participate. That's the ultimate target, not like a person talking.
Okay.
I'm not saying this that I'm gonna be tired, you guys talk. Not like that. But it's gonna be interesting if you participate, right?
Yeah.
Yeah. So this one, very quickly, this is like a very common information. It's like 128 bits. Somebody say, why it's too long? I don't need that. One of my previous boss, he said, why IPv6 is 128 bit? I don't like it. Can we make it like 64 bit? I said, yeah, you need to go to the IETF conference and fix this, right? Anyway, so this is really a big number. It's a big number, but gladly we don't need to deal with it much. Computer deals with it. We don't need to remember or process it in our head. Like, there's too much information. It is presented in hexadecimal numbers. So that's a change from IPv4. IPv4 was a dotted decimal. Right? You use dot to separate the octets. There have been 4 octets and total number 32-bit, and that's why it is called dotted decimal, because the binary numbers has been represented as decimal, because human being understand this better. But the computer understands decimal, binary, hexadecimal, octal, many other different numbering systems. Why hexadecimal? Can you tell me why IPv6 addresses are presented in hexadecimal?
Karena untuk jumlahnya bisa lebih besar atau lebih banyak IP yang bisa dipakai buat.
I think is the right answer. Is the right answer? I don't know.
Bigger IP address space.
Versi 6 lebih besar dan alokasinya juga lebih banyak.
Yeah, untuk allocation, bigger allocation for IPv6 address space. Yeah,
Address space, ya.
Okay, let's say 128 bit.
Yes.
If I present it binary, decimal, like IPv4, wouldn't it better like 1 to 9, no ABCD? Why the engineers still choose the wrong path, the difficult one? Why? They want to kill themselves, right? Yeah. there are a lot of ways to kill a person, right? And why they're not the easy way? Why the difficult way? So there is a, but still you get, because you were answering, so thank you. So decimal numbers have to go until 10 numbers. Every time you go to 10, you add a new number. But hexadecimal number, you can go up to 16 number and then add a new number. So squeeze the total number into hexadecimal will look like smaller. But if you use decimal, it's even bigger. That's because the base, radix, it's called the radix. Binary is 2. So that's why binary looks very long. Decimal is better, a little bit better, because it can go up to like 10, because its radix is 10. But hexadecimal is 16. That means you don't need to, with one character, you can go up to 16 number. Actually up to 15, because you start from 0. But you don't need to use 2 numbers until you go. But for decimal, you go 9 and then you need to use 2 digits. Right? So it makes this address smaller if you use hexadecimal. The other benefit is the MAC address is hexadecimal. And now you can use MAC to add to IPv6 address to automatically generate the address. Right? You don't need to do any magic or something like this. But computer is gonna do the magic, but it's a process wall. So but anyway, each hexadecimal digit is called a nibble. A nibble. So one hexadecimal number is 4 binary bits, right? So one nibble is 4 binary bits, right? So this is the idea. One nibble means one hexadecimal number. So let's say 2. It's a hexadecimal number. It's a nibble. And this 2 is basically 4 binary bits. Here, if you can see this one, A is 10. So 1, 0, 1, 0. This one is 8 and this one is 2. Altogether it's 10. I'm not going to go to the math of how to convert this, but one hexadecimal number takes 4 binary space to convert the number. And these 4 numbers is called nibble, because I think it's a PDF, it breaks the format. Like that was I saying, like if you convert the PDF is breaking the format. So this nibble is not, so this 4 is a nibble, okay? Okay, next up. How you can even make it smaller. So like I said, engineers are really not very good. Not very good. They first created the problem, make it 128-bit. And then they're trying to fix this problem by making ideas, how I can make it smaller. So first they generated an idea like, let's make it hexadecimal. Still it's 32 hexadecimal digits to write 128 bits. 32 hexadecimal numbers. And then they say, okay, it's still too long, 32. Let's make it even smaller. How? If you have a 0 at the front of a hexadecimal hexstate. Hexstate means a number between colons. Remember octet, 8 bits space, hexstate is 16-bit space. So this is a 16-bit space, this is a 16-bit. So if you have a 16-bit space and there is a 0 or multiple zeros at the beginning, you don't need to count them, you don't need to write that. Computer will think about it, but human being no need to write it. Just to make it even smaller. So 0 dB8 can be written as dB8. Right? How about this one? 1250. Can we write 1 to 5? No, because this zero actually have values. This 0 is like money, right? If you have 0, then you understand money better than IP, of course. So we all understand that. So yeah, that's valuable. That cannot be omitted. But this one can be omitted. Now think about this. All the 3 zeros can be omitted and can be written as 1 0. Just 1 0, right? Because you don't need to write the front at the beginning. We have a couple of zeros. Now the second rule says, so it can be written like this, 2001 DB8, 000, and then like this. Now the second rule says, if you have continuous hex state of zeros, that means all zero, continuous, then you can remove all those hex state of zeros and can just put a double colon. It's like, yeah, it's like start from this 0 all the way to 0, just maintain this colon and this colon. So it will look like something like this.
Okay.
Right? So there are two rules. If you have 0 at the beginning of a hex state, you can omit those zeros. If you have continuous hex state, all zeros, all 16-bit 0, then again all 16-bit 0 again. So if you have these continuous examples, you can omit them and just put a double colon. The thing is, you can use double colon only one time.
Ingat, hanya sekali saja, only once.
Only once. You cannot use twice. Why?
It will be confused.
It will be confusing. If you use twice, how many zeros are replaced by the first one and how many zeros are replaced by the second one, computer will not understand. If you confuse the computer, you will be fired. Simply, you will be fired and you don't need to do the job anymore. Find another different job, not network engineering. So don't mess up with computers. Be like loyal to them. Be very good friend. Okay, no. So you can only use once because that's why. Then they will understand 1, 2, 3, 4, 5 hex state. That means 3 is missing. Those 3 is definitely 0 and within the colon. That they will understand and they will work it out. Very nice and friendly. Okay. So if I have multiple occurrence, now I cannot do twice, but I can do once.
Okay.
Right? So I can do either this set of zeros with a double colon or this set of zeros with a double colon. But if I use this set of 0 with double colon, then I have to maintain this double 0 here. I cannot replace them. Okay? If I use double colon here, then I have to use
2.
here
Or
there is a
3
mistake.
0.
Here is a mistake, right?
3.
We need to
Yes.
have 3
0.
zeros. Oh, so look at this. Look at this. This one is right. So if I use double colon here, I need to maintain 0. If I use double colon here, I need to maintain these 3 zeros here,
Hanya
right?
sekali saja. Diagonal only once.
That's only
So,
one.
so both are correct. Okay, there is no mistake here.
Yeah.
Both correct. As long as computer understands what you want to say, all okay.
Mau yang depan atau yang belakang sama saja. Correct.
Yeah. But what is the recommendation?
Recommendation.
Here? The recommendation is, if you have this occurrence, oh sorry, this one is a different example. This is the this one is different, not a mistake, but a different example. Okay, so this time, you can use the bigger number to replace instead of the smaller replacement. Then you can actually making it much smaller compared to the other option, right? If you have more zeros, you replace that, keep the other one as it is. But if you have the equal numbers,
Okay, equal number.
which one you should do? The first one.
Bisa.
For the equal numbers, do the first one. No need to go. But I say, if you do the opposite, it's just all okay. No problem with that. But that's a recommendation.
Recommendation.
It's just for your, you can practice that. But whatever you do, you should maintain this with all your engineers, like all your colleagues. For example, you are doing this first double colon, and your colleague doing the second double colon, and when you check the planning, it's like different. It's not a technical problem, but it's like a management, a difficulty. So try to be synchronized within your office, within your colleagues. How you write the prefix? It's a slider format. Prefix / the size. But in IPv4, we had like something 255, 255. Now this time you have to write 32, right? It's not a good idea. So that's why you can just write / something. Right? Okay, quiz. I don't have much time to do this quiz. Let's do it quickly, okay?
Yes.
Who can help me short or compress this one? First one. Who can help me?
Oh, tulis.
Let me go to the other side a little. Yeah.
The first one is 2001:DBA::.
Colon.
Double colon.
Do we need colon 0? The last this is
Double colon.
no. So 2001:DBA::. That's it, right?
Colon.
No need to put any 0 at the last, like double colon and then a 0.
Yeah.
No.
No, colon.
You were right. I was trying to make you confused. And
Kita lihat balik nggak jadi
you were right. So
Nggak apa-apa.
second one. Who can help me quickly? Yeah, please try.
2001.
2001.
2001 kolon DBA double colon D170 100 DBA8.
So you mean here?
Yes,
Zero.
Zero.
Yeah.
Zero.
And then here
100.
100.
One,
That's
zero,
right.
zero.
That's correct.
Yeah.
You don't need to use the first.
Yang penting dapat hadiah.
How about the? Any question? Is there anybody who didn't understand?
Yeah.
Belum paham kan?
Anybody? Anybody understand?
Bingung.
Bahasa Indonesia
When
aja Mas.
I used to be in the class, and when the instructor was
Yeah.
saying like, who didn't understand? So I was like, I don't. Yeah. So, is it? It's easy, right? Easy. So, can anyone help me with the third one?
Yang nomor 3.
Maybe, yeah. Thank you for volunteering and thanks as well. I cannot give you the chance yet. Sorry.
Nomor 3 2001 kolon D8 kolon 2 A0 artinya 000 terus misalnya nggak diubah
Oh, belum. Yang ini terakhir.
yang nomor
Oh, 3.
Yang ini kalau ya yang 5 1 2 3 4 6 7 yang posisi 6 itu.
So there is a one here, one here.
Nah, pilih yang mana?
depannya pakai kolon 2
Kalau 2
enggak yang pertama kolon 2
Ya.
yang keduanya pakai yang 0 iya 01 aja
Udah, dari sini udah diwakili.
Thank you. Thanks so much. Thank you.
4 kolon.
So 2001 DBA double colon A0 00
Zero ya,
10
bisa ya.
BC. Fourth one, last one, very quickly.
You already
You already answered?
No.
Yeah.
Okay.
Okay.
2001 kolon DB8 kolon FC5 kolon 7B kolon AB70 kolon 210 kolon 0 kolon BB.
Okay, that's not wrong. But because this is the only
Oh,
option,
okay.
you can use even
Colon,
double colon.
colon,
Because
okay.
that's the only option you have. So
Okay.
thanks for that.
Okay,
But
thank
it's,
you.
It's also right.
Yeah.
If you want to write everything, that's also right. I mean, if you can just write everything, that's also right. If you shorten, that's also right.
Okay.
So you need to try the much shorter.
Yeah.
The more smaller, it's easier. Right? So,
Okay, thank you.
there are several interest types, and not everything I'm gonna discuss today here, but I'm gonna give you a brief idea. Please spend some time when you go back, spend some of your own time and try to understand more about it. So in IPv4, we had 4 types: unicast, multicast, broadcast, and anycast. But in IPv6, there is no broadcast. Rest of the 3 is here. Now, what is unicast? One-to-one. I'm gonna talk to Google server. That's a unicast. What is multicast? I'm gonna send a packet to a group. For example, what do we have as a multicast address? For example, OSPF DRVDR selection, right? Multicast packet. Broadcast. Can you give me one example, interesting example we have in our daily life in network? that uses broadcast. A good protocol that uses ARP, that needs broadcast. And that needs to send the unknown destination to everybody and then try to understand that. That's ARP. Now, because we don't have broadcast in IPv6, ARP is not going to work. Right? That's the problem. So the engineer needs to invent another protocol. That's called Neighbor Discovery Protocol, NDP. We'll talk about it later. That's a replacement for ARP. That works with multicast. So multicast is when you send, for example, here I'm speaking and the message is going only meaningful to the participant in the room. Even if the door is open, if somebody understand or listen to that, doesn't make any sense for them. So that's like not a broadcast, right? It's just a multicast to a group. Anyway, so in IPv6, because there is no broadcast, multicast is heavily used. Multicast is very, very important in IPv6. And there are, for unicast, there are several types. Multicast, we have some assigned multicast address. So whenever you see FF, that's a multicast address. Doesn't matter what other numbers are there. If it starts with FF, that's a multicast address. Okay? For example, in IPv4, if you start with 224, that's a multicast address. 224 means multicast address. Doesn't matter what the other numbers in other octaves, right? Here, FF, and then that's a multicast address. We'll come to this number, FF02. That's an interesting multicast address, but let's talk about it. Unspecified address. When your computer first starts, it needs to get, so IPv6 has this auto address configuration. Your device can automatically generate its own address. But how it will know that this is a unique address, no one is using it? It needs to claim the address, right? So the first claim needs a source address, but the source is not yet using the address because it's verifying the address. So what would be its own address? Its own address will be unspecified. So any computer first opening up, try to get its address, will use its own address as this number, all 0/128. Okay? Loopback in IPv4. What is the loopback?
Loopback IPv4.
What is the loopback?
127.
127?
0.0.0/8.
0/8. You are really very, very good at this. This is a very good answer. Some people may say 127.0.0.1.
Oh,
Right?
yes.
But you are right. If you ping 127 and then any number, your computer is going to answer. Yeah, you can test. Like we always think maybe loopback is only 127.0.0.1. You can test any number, your computer is going to answer. But because in the host file you have only .1 as the local host, that's why you think like this is probably the only address. But it's a /8. Any number, the computer is going to answer.
Yeah.
No problem with that. So that's why your answer was actually correct. In IPv6, loopback is just one number, not a /8, because IPv4 reserved a /8 just for only one address.
Yeah.
That's a waste of address, and now we are suffering. Now we don't have IPv4 anymore because we have a big number reserved for unnecessary tasks. Because of that mistake, now engineers understood, okay, that's a mistake. Let's fix the problem and use only one address for loopback. So there will be only one, all 0, but at the last it has just 1. So $1/128, right?
Yeah.
Embedded IPv4, I'm not going to talk. So you can add your IPv4 address within IPv6 address. So that's called embedded IPv4. Sometimes it is required. Global unicast is the public IP. So you will see in your public IP, it starts with either 0 or 3, either 2 or 3. So 2000 or 3000 something, it's all global public IP. You will not see any public IPv6 address other than these numbers. So let's say 2024, 2005, these are all public IP. You cannot see 8000 a public IP, no, not yet. Maybe in future, not yet. Link local, very important, actually the most important, according to me, it's the most important one. Because you cannot delete any link local address. Any computer, once it is up, the interface is enabled for IPv6, it will generate some address automatically, starts with FE80. And that's called a link local address. And that's automatically created. You can manually create as well, but you cannot delete any link local address because it is mandatory. The link local address is mandatory. If you define something, then you can delete it, no problem. But the automatic one you cannot delete because it mandatorily needs that address. Without that, IPv6 is not going to work, okay?
You can check on the CMD via.
Yes, that's right.
Yes. On.
Yeah. Let me show you quickly.
Ya. Di laptop masing-masing yang sudah terkoneksi WiFi biasanya ada FE80 itu tadi ya.
FE80.
Ya, config atau kalau di Windows itu ipconfig/on.
/on. Ya ada.
Ada ya?
Ada. FE80.
By the way, SSID-nya IDNIC juga sudah IPv6 ready ya Mas ya?
Yap.
Jadi bisa dicek di situ.
Nah ini ada nih.
Walaupun belum masih terkoneksi ke network IPv6 tapi sudah ada.
Ini ya FE80.
Iya, FE80.
Itu pasti ada.
Berarti laptop sudah siap digunakan untuk IPv6.
Luar biasa.
Begitu nanti join ke SSID IDNIC itu udah dapat IP public global unicast tadi bisa diakses. Coba kalau misalkan
domain.
Nggak tahu ada firewall yang untuk ya. Ada SAMPP apa?
Ini ya, pinggir.
Yeah, so you
Ya,
can see.
ya itu.
You can see that there is a INET 6 address, even though my computer doesn't have IPv6 connection
Memang harus pakai domain.
in this
Tapi itu
in
kalau
this
misalnya ada server di
premises,
laptop itu
but
bisa
still
diakses.
it generates FE80.
Public lah ya.
Interestingly, if you go here, it's also FE80.
Every interface is.
If you go here, it's also FE80. Every interface will have IP from the same subnet, which is impossible in IPv4.
Okay.
You cannot have the same subnet. Your computer will say, your router will say, you already use this subnet on that interface, you cannot use it in a different interface. Because every single interface in a router is a different subnet. But in IPv6, this is possible and this is the link address. It's coming up next. Which one I was presenting? Okay, so link local will come to that as well. Unique local is the private IP in IPv6, okay? 172.16.00, 192.168.10.00, something like this. All the private IP address you have in IPv4.
Yeah.
In IPv6, though the IPv6 has been created for public IPs. That was the intention as well, but sometimes you may need private IP. For example, you have a printer in your house, and the neighbor is going to print. if you don't provide security there, then somebody is going to print in your printer. So you may sometimes need private IP. You can use public IP, and then can filter at the border, not people entering that network. That's possible, but sometimes you may need private IP. Just a reservation. If you need, use FC. Anything starts with FC or FD, there's a private address. Okay. If you're doing some research at home, at office, need some IPv6 address, you can use it from there. There's a huge subnet. It's a big subnet, /7. So many addresses. You can use it. This is a kind of a diagram that we use just to give you an idea of how the subnetting is done. For example, if you have a network prefix of /32, you can actually do subnetting with 16-bit, and you can get /48 subnets. If you have a big /32, you want to split into multiple smaller subnet, you can make /48. You can of course make /36, /40, something like this. I'll come to that quickly. But there you have a 16-bit to subnet to /48. That means you can create 65,536, that many number of /48.
60.
65,000.
5,000, 65.000
Subnet.
slash 48.
Slash 48 preferences.
Jadi banyak sekali.
From 1/32, you get 65,000 plus slash 48. With 1/48, you can get another 65,000 of slash 64s. And after that, don't need to do subnetting. You are already tired and
Sudah pada punya IPv6 kan dari
IDNIC.
Do you have already have IPv6 from IDNIC?
Ya. Tapi nggak dipakai.
They kept it in the freezer or in the locker.
Yeah.
So it doesn't get stolen.
Because
It doesn't get stolen.
we don't know how to
Don't
use it.
touch it. And even if somebody want to touch it, you have to defend. You cannot touch that. That's our property.
Ya.
That remains there until I leave the company. You cannot touch that. That's like a precious, something, a valuable thing. You're locked inside. It's not underestimating anybody. Just it's like a frightening thing.
But it's real.
If anything happens, who's gonna take the liability?
But the fact that
It's
not already implemented because too long to
Today we are gonna fix this mindset. So it will be a success today. After our lab, if you have the frightening idea gone, and then you are more comfortable and confident, that would be the biggest achievement of this workshop today. Okay. So yes, after 64, it is not recommended to do subnetting anymore. 64 is the minimum LAN subnet in IPv6. Now, people always ask this question, and that's a very good question as well, that why so many addresses just for one LAN? Okay? It's just there. No need to think about the wastage. Okay? Because you cannot achieve everything with one solution, right? So wastage is not a matter here, because you have so many addresses. Don't bother about this, okay? And that's also save us from some calculation. Remember in IPv4, we had the course where we did in university. There's a question. In a LAN, you have 200 users. What is the subnet size? Now calculate. Right? That question, right? Always we had this question. I had a friend. He failed his CCNA exam twice because of this, and he was like very upset. Why this type of question? Now, if you have 164, you don't need to think how many users are there. Just give them 164. You bring how many numbers you need. Just take it. Right?
It's only one host, use 64. If 1,000 hosts, 64.
64. 1 trillion. Couple of trillions. Just feed them. We don't need to bother about it. But that's engineers are very, very funny sometimes. They don't even understand how funny they are, right? Link local address, automatically generated. It's similar to automatic private IP addressing in IPv4. It's called APIPA, and APIPA is not a girl's name. It's a short form of a big name. So it happens when you don't get a DHCP server. You get 169.254 and then any number as your IP.
Iya, kalau nggak ada
Right?
Di
IP.
Windows jadi gitu ya.
Why you get this number? Because at least you can talk to anybody local. That's why it's link local. You don't need any address. If your computer gets 169.254 any address and your computer gets the same subnet, and you guys can talk to each other. That's locally possible. It's not a prefix that can go out, but it's a link local. Same thing happens here, but this time it's by default. Doesn't matter whether you fail to get an address from a server, the DHCP, or not. Always you get this address. And one interface can get multiple IPv6 address. So link local, mandatory, and then on top of that you can have more addresses. Okay? Link local is very important, like I mentioned. This is, according to me, it's the most important address in IPv6, because your computer talks to the gateway, with linked local address. Even though it has a public IP, I have a public IP in my computer is going to the gateway using linked local address, not public IP. Even if I try to go to the Google server, I'll pass the packet to my gateway, right? And I'll use the linked local address, right? So that's a very, very important one. Not only that, routing protocols, when they talk to the neighbors, the OSPF messages, the BGP messages with the neighbors, everything happens over linked local address, not over the public IP. Even though you configure clearing public IP, because linked local by default there and you cannot remove it, it will use that. That is more trusted. That is more trusted. Not trusted actually. This is like a preference. It will just use it. Now, here comes the problem. Oh, who fixed it? Thanks so much. Thanks so much. Now the problem is that it's like this, right?
Coupling
Yeah, should be okay, right? That's engineering. Yeah. Now, I have to use my old way of. I used to do this when I used the chalk. Chalk on the board, the slate. Okay, this is interesting. Please try to understand this. These are the tiny bits that you can also check later, but we're gonna quickly cover this. Okay. This is router 1. It has Ethernet 1, Ethernet 2, Ethernet 3. Is it possible to see from the back? Somebody, okay?
Television.
Nice television.
Oh, camera.
monitor.
IDNIC is so innovative and just thinking it's a very good idea, like having cameras. Yeah. So, this Ethernet 1 has an address that starts with FE80/8, right? So 10. This one also have FE80 and then 10. This one also have FE80, something like this, right? This one you need to understand really. So please give your attention. If I have some devices here, they will have similar address, and that's why they are the LAN. A LAN has to be of the same subnet, right? Any computers here will also have same subnet FE80. Any computer here will have the same subnet FE80, right? If this router needs to reach someone here, which interface is going to pass? Because in the routing table, all 3 interfaces has FE80. That's a conflict, and that's why router says you cannot use the same subnet in everywhere. That's a confusing thing for me, and you don't mess up with a router. Right? Router always, remember I told you, don't mess with the computers. They need logic. So this is illogical. Seemingly illogical. That's why they need to add something else to make it unique. So every single interface has something called zone ID to make it unique. So this interface will have a zone ID that's different from that one, that's different from that one, and it's actually added at the last part with a percent sign. Now if this interface has a linked local address FE80 and then something and then finally %1, for example, and this one has FE80 and finally %2, or maybe here %3, something like this. Now that becomes unique. The numbers are not now matching because they have at least one digit which is different. And that's a zone ID. And many different vendors make it different way. In Mac OS, you will find something like this. Something EN0, interface name. In Windows and servers, you will see just a number. In Linux, you will see something like this. So now, if you want to send a packet to this network, you have to say the zone ID along with the IP. Okay? So if you are PC A, you have two interfaces. Both of them has FE80, but because your operating system knows that I have to add a unique number as a zone ID, it adds two different numbers here. And let's say you are connected to another computer and then second computer with two different links. Now let's say I want to ping from here to here. Okay? If I use FE80::B1, then its routing table has both interface with FE80 subnet. Which interface is going to send? That's the problem. What it needs to do is to add the zone ID with the destination as well. So this computer needs to add this IP along with the zone ID. But which zone ID? Is it 12 or 20? 20. It's going to be 20. Why? Because the computer knows only its own zone ID. It doesn't know about the other zone ID. So it needs to say, okay, pass the packet via this interface. And the IP will be that IP. So other end IP, but your end's zone ID. That's all protocol will do. You don't need to do that. But if you want to test ping in IPv6 with your immediate neighbor in a computer manually, you need to add zone ID. But the protocols, like I said, router will talk to the gateway using link local. The computer understands that, okay, I need to add zone ID. You don't need to bother about it, but you just need to know that this is something happens. Okay. Modified EUI64. This is the format, but it's not popular anymore. It's called Extended Unique Identifier, and it's given by the name is given by IEEE. IEEE standardized the MAC address. IP is standardized by the IETF. So they're two different organizations. IEEE, I'm pretty sure you have heard the name, Institute of Electrical and Electronic Engineers. So this organization, when they invented MAC, they used 48-bit number, hexadecimal representation. So there will be 12 hexadecimal digit multiplied by 4, 48 binary bits, right? Yeah. Now the thing is, that's why it's called EUI48, okay? But we need 64-bit in IPv4 to create the whole address because our subnet size minimum is 64. So there is an automatic address calculation or creation opportunity in IPv6. Sorry, that's going to be done automatically, but that use the EUI64 because the bit number is now 64. But you have MAC address of 48. How many bits remaining? 16. How you can create it? Let's say your MAC address is like that. You split it in the middle, and then add FFFE. That's defined by IETF again, saying that if you want to, sorry, it's defined by IEEE again. IEEE says, if you want to convert a MAC, which is EUI48, to address, which is EUI64, just add FFFE in the middle, and then that's FFFE means 16 binary bits, right? 4 digits multiplied by 4 binary bits, so it's now becoming a 64-bit number. And it actually modifies the 7th bit from the left side. If it is 0, it converts to 1. If it is a 1, it converts to 0. Okay? So this way, but this is not popular anymore. It's only popular for the routers, not for operating system like computers. Computers don't make static IP because then you can recognize, you can track people. That's a privacy violation. If I know your MAC, I know your IPv6 address. That's a privacy violation, right? So that's why computer randomly chose the 64-bit, and it changes after a couple of times, after a couple of minutes. It's a security feature. Like I said, it is important for routers because if router interface IP changes after some time, your OSPF neighbor will gonna refresh. It's gonna reset. If your BGP interface or IP is changing, then it's gonna change the neighbor relationship as well. So that's not a good idea for routers. Router needs static IPs. So if you give a prefix, it will generate from its MAC address like FFFE, adding, and then it will create an IPv6 address using this UI64. So it's not important to understand at the moment because we don't need to really think about this. It's going to happen in the background. This is like something I told you that I'm going to cover this one, FF02. FF means it's a multicast address, right? So we need to know some of this. If I want to reach everybody in a group, I'll use FF02::1. That's for everybody, computers, routers, any other layer 3 devices like switches, okay? Everybody, if I want to send a message to everyone, that's going to be my address. It's like a broadcast, but within the group. That's why it's multicast. If I want to go only to the routers, then I'll use FF02::2. That means my laptop always listen to this IP because it's part of the group, but it does not listen to this IP because it's not a router. My router listen both of the groups because it is a node at the same time is a router. Okay? For example, my computer automatically created its own address. It needs to find the gateway. So it will send a packet to this IP because a computer is not a gateway, a router is a gateway. And all the routers in my group are listening to this address. If I ask their help, they're going to respond. But if I need to find MAC address of some other computers in my network, I'm going to talk every single door, I'm going to knock them and say, do you have this MAC address? So that's going to be the first address that I'm going to send. So they have different reasons of grouping them into multiple, and one device can listen to multiple group addresses because it actually belongs to those groups. At the same time, it is a router. At the same time, it is a device, like all node. Understand this? Do you understand? These are going to happen in the behind our knowledge because the computer is well equipped with this. It understands that. This is another interesting one. If you want to use NDP, Neighbor Discovery Protocol, I mentioned it's a replacement for ARP, Address Resolution Protocol for before. We now have NDP, Neighbor Discovery Protocol. So I will use this address because everybody is listening to this number, right? This one is from here. Everyone listen to that. And then I'll add the person, the device, the destination that I want their MAC address. I'll just add their last digits. If anybody listen to that, they will respond. But that message is going to go to everybody because the prefix has the number. So everyone is going to listen, and then if I see my name is there at the last part, I'm going to respond. That's the idea, right? If I want to get DHCP information, all the servers and relay agents listen to this, and all DHCP servers listen to this. Okay? So there are every single function is actually having one single group address, and that's how broadcast is replaced by multicast.
This is a broadcast for more segmented, yeah. More
segmented, that's true, that's right.
Not all one room, but if I will talk to the HTTP, I will go to 1.3. Yeah. If I relay, it's 1.2.
Yeah, that's true. So this is the idea, like because in IPv6, if your router gets a broadcast, it's gonna block it. It's not gonna pass. It will block it. So no broadcast is gonna pass any device in IPv6, not only the router. So that's why you have to find a solution for multicast. Now, you also need to understand these 4 different types. I think you understand as well before you have, if you have any IPv6 conversation before, these are very important 4 numbers. Redirect is same as IPv4. But router solicitation, router advertisement. I'm going to try to make it simple for you so you can remember that. If you look for a router, you send a router solicitation because you were looking for router. If there is a router, it's going to respond, and that's called router advertisement. The advertisement is done by the router, right? When I need a router, let's say I just turned on my computer. it generates its own IPv6 address. But without a gateway, it cannot go to other network. It can talk to within the LAN, but cannot go out. That's why I need a router.
The other segment we need the
Routing functionality. So that's why I need to look for routers saying that, hey router, can you give me your address? And I can generate my own address with matching with your IP, so we will be in the same LAN. And then you can take me to other LANs. So that's when I send something, that's called router solicitation. If router sends something to me, that's router advertisement. Similar concept for neighbors. If I look for a neighbor, it's called neighbor solicitation. If they answers, it's called neighbor advertisement. Okay? When I need that. So first time you understand when I need that. When I need this. I need this when I need to know whether my address is already used by somebody. I turn on my computer, it generates its own address, but it needs to make sure that this is a unique address, not anyone else, because everybody is generating their own. How can I make sure that my address is not yet used by anybody? I need to check the uniqueness, and that's called duplicate address detection, DAD mechanism. If I want to check, only way is, for example, in this room, if my name is used by anybody, I can identify, I can just ask my name. If anybody responds, my name is not unique. If no one responds, then that's a unique name. So what it will do is, when it turns on, it will send a message with its own address as destination, and will wait whether anybody is responding to that. If any response comes, that's called neighbor advertisement. But in this case, if response comes, that's a problem. That's a duplicate address. You don't expect any response. Usually, because it's a 64-bit number, usually it's a very less chance that somebody else is using that. But even it is using, I'll create another one and again send a neighbor solicitation. I'll wait for some time. If no one responds, that means my address is unique, right? So that's the neighbor solicitation and neighbor advertisement. I might need this for another reason. I want to send a packet to my neighbor, and I need their MAC address. So I'll send a neighbor solicitation. Their reply will contain their MAC address, then I'll use. Similar to ARP, right? So these are two reasons. There might be other reasons, but two useful case of why I need this. Okay? You got it? These are four important concepts I need you to take. This is very important. Now tell me, so one information I haven't yet shared, router advertisement is not necessarily a reply. It can be voluntarily sent by the router unless you block it. Okay? Now let's say, think about both scenarios. These are important because we are gonna use them in our lab. And these are real technical things. You don't need to learn all the networking like very theoretical concept. I want you to take the practical things. I'm saying I'm a router. After let's say a couple of minutes, I'm sending you my information. Okay? And why it is important? Let's say my computer just turned on. If I get the information from the router, I can immediately generate my address. I can generate and use that address, right? To talk to my gateway. The other thing is I can send router solicitation willingly and they can respond. That's also a solution. Okay? Now when I should send voluntarily to my LAN and when I should not. Let's say, so this is important to understand. Like you said, I'm taking actually longer time than expected. So think about, this is my gateway, okay? And this is my computer. This gateway can voluntarily send after some couple of minutes, you can configure that and then it can just send the router advertisement. It doesn't matter whether anybody needs it or not. You just give it, right? For example, television advertisements. Router advertisement and television. Doesn't matter whether somebody is listening to that advertisement, Oppo, blah blah blah. Not Oppo. No offense to any advertiser, but let's say their advertisement. Is everybody listening to? They don't care. They don't care whether everyone listening to that or not. If somebody listens, that's their intention. Now, the router sends the advertisement, doesn't matter whether it's useful for its LAN or not, but it's just gonna send. Now, if this is a user LAN, you can turn it on because you know anytime user can turn their laptop on, they need the gateway address. Okay? But I have a peering here with another router. And I have configured IP here, let's say here 1, here 0. Okay, these are my addresses, manually created because this is my peering IP. Now, do I need to know the other router's address? Do I need to get their router advertisement? Because I already configured the address, I don't need their advertisement because I'm not going to use that. Right? So I have to disable it. Not mandatory, you can keep it turning on, but what's the point? You are using your resources for nothing. So when you have fixed addresses, no need to turn it on. Most of the vendors' routers by default turn it on. So we'll disable it when we don't need it. It's called optimization. It's not mandatory, but better to optimize. Okay? Everybody get the point? We're going to configure this in our lab actually.
So you ask one question about the router solicitation. Solicitation.
Yeah. Okay.
If we have multiple router,
Yeah.
and this also send a router
Yeah.
solicitation,
Oh yeah.
which
Which
is,
router?
Oh, very good question. Unfortunately, I cannot give you a.
Give you.
no problem.
Yeah, very good question. You understood this, right?
Yeah.
That you have multiple gateway.
Yeah.
Both of them are actually sending you the advertisement. And when you send router solicitation, it also received it both. So they're gonna respond as well.
Yeah.
So which one I'm gonna use? The faster, whichever comes first, I'm gonna take that.
Faster.
Now, this is the idea. But there is something called ICMP redirect. If this one is a better path, this router will tell me that this is a better path. You can choose that one. But usually we disable that. We don't want somebody, because we optimize our routing. This is not a common scenario. Think about it. This is not a common scenario. If you do it, you know why you did that. And then you know which one is better path. No need to depend on ICMP redirect to redirect your traffic to somewhere else. Because then you don't have control. And that's not a very good choice. But yes, whichever comes first is going to take that. Now a hacker, and that's a weakness in IPv6. And tomorrow I'm going to present something in the conference which covers some of the topics around it. If you are joining tomorrow, feel free to attend that part. So if a hacker in this building and comes and just turn on their fake router and continuously send faster gateway messages, then you are receiving it and you are going to a different direction. So that's a weakness, and we have solution how to do that, to block it, right?
Yeah.
That's called rogue RA. That means fault array or malicious array messages. You need to. That's a security configuration you need to do. That's a good question. This is a very, very good question. Next up. Okay. So Slack. What's Slack? I think it's the most commonly used term in IPv6. Stateless address auto configuration. Stateless address auto configuration. That means there are a couple of concepts here. Every term has a meaning. Okay. What is the auto configuration? The ability to create by myself automatically. Stateless means no one is gonna keep any record of it. Stateful firewall. Firewall remembers the session's information to inspect. Stateless, it doesn't. Stateless NAT, stateful NAT. Okay, so if the NAT sessions are remembered, that's a stateful. And so this is the idea. If I create my own address by myself and start communicating, and there is no DHCP server, no one is going to keep record of which address I'm holding, right? So that's called stateless, and that's what the most easy configuration in IPv6. You turn your laptop on, if the router advertisements are enabled, you're going to get them connected immediately. Now, if your company wants to know which MAC address is using which address, you need a stateful DHCP, which is similar to IPv4 DHCP. So DHCP can be two types, stateless and stateful. And then on top of that, you have Slack. So there are three types. Slack is the simple one. No one is going to record it because you are not dependent on any DHCP server. You can generate by yourself, and you can talk to the gateway by yourself, right? Using the router advertisement, router solicitation. So Slack, and then you have DHCP v6, another solution. It can be two types. One is, in my next slide, one is the stateless and the stateful, but let's first cover this one. So let's say my computer turned on, it has a linked local address. Now it needs to know whether this address is unique or not. It needs to perform a DAD function, a duplicate address detection function I already covered. It's gonna use its own address and send the message to everybody. If no one responds, that's a unique address, it's gonna use that. So that's how it gets its auto configuration done. But with the, now I need gateway, so I'm gonna send a router solicitation. Router is gonna send me the packet, and I'm gonna use the gateway address, the router address. Now here comes the DHCP v6. I mentioned that there are two types, stateful, stateless. Stateful DHCP is called managed DHCP or managed flag. Okay, what is managed flag? Like IPv4, in IPv4, by your DHCP server, you get your IP, your gateway, your DNS, your domain, your search information, things like that, right? These are the info. Mostly we get three: IP, gateway, DNS, right? And when you ask this address, the DHCP server, when distributed to you, it tracks you. It stores your MAC information as well. Okay. So if I'm a DHCP server, I'm giving an address. I'll write it down, saying that this MAC address is using that address, so that this address is not given to anybody else, right? Next person comes, I'm going to give the next available address, and I'll still keep. That's called stateful DHCP, and that is why we call it managed. Everything managed by a server. Okay. Now, what is a stateless DHCP v6? This is not available in IPv4, but we can make it. Remember, in IPv4, if you get DHCP information, you can still change the DNS by manually. You don't want their DNS, you can use the 8888, right? You can use that. So that's called other information. So you get IP, you get gateway, but DNS you get somewhere else. Okay. So this is something. So that's it. I think I actually took more than expected time, but I hope there are some concepts that made clear to you. Is there any question?
Ada pertanyaan nggak?
Yeah, please go ahead.
Aku ada problem Android device that using only IPv6, but the Android device just get the IPv6 IP, not the DNS. And in the Cisco router, I using the Slack.
Yeah.
And it's
IPv6 only berarti ya?
yes, and using the DNS 64 and not 64, but the Android device cannot get the DNS IPv6.
Okay. If I understand the question correctly, you have Slack enabled. Your device got IP information but no DNS information, right? Can you reach the internet?
No, but the Android device still reconnecting, trying to get the IP4
Okay.
IP.
Okay.
That's it.
So for Slack, you don't need DNS because Slack is auto, means you are relying on your gateway's DNS information. So your DNS, the gateway must have DNS. So just make sure
Jadi nggak perlu DNS lagi.
for Slack, I just need the router's information. I generate my own address. I don't need a DNS there. I will pass query to this router. Now this router has to have a DNS configured. Then it's gonna grab the information from me. For Slack, I don't need DNS. I'm gonna relying on my gateway. Now there could be other problems. I'm pretty sure probably you have already configured DNS, but it's still not working. I may need to take a look at it because that's not a difficult one. It should be fairly easy unless there is some issues in the configuration. So Slack, you don't need DNS. You are gonna use peer DNS. So the peers that the gateway's DNS you can use, no problem. And we can, do we have Slack lab? No. We have labs in APNIC Academy you can test. It should be easy. No issue. Unless, as like you mentioned, that your device is waiting for IPv4 address, right?
Yeah.
You say that your device is. I have run V6 only network, so there shouldn't be this problem. I did a similar conference where I gave V6 only address to people, and they didn't know that they're using V6 only. But I tested it and it worked. So it shouldn't be a problem. But if you still want to take me a look,
Oh iya.
I'll show you how you can book a session with me, and it's like free of cost. Are you a member APNIC or IDNIC member?
Fisik
You
ini
can-
nggak bisa diakses sama kita.
You
Harus
can
putar
take
terus.
one of our session and I can take a look. I'm not so sure if I can fix the problem, but I can at least take a look at it.
Harus dilihat dulu, terlalu spesifik mungkin ya.
It's like a about 1 hour session.
Iya.
You can just book it from. I'll show you how everybody can do that actually. So, quickly with the address planning, because like I said, we are on roller coaster. You need to. You cannot go back. You cannot do anything. Like you just need to sit.
Don't forget to do it. Awal.
Yeah.
Don't forget to do it.
Oh, sorry. Oh, wow. He must have. Tell the trainer.
Bit topping the game.
Anyway, that's a good question. Thanks so much. Yes. Sorry to forget that sometimes the flow of. Okay. This one. We'll take a /32 and then we'll split it to make a good plan for our network. Okay. So let's say we have this /32. And we will delegate our customer with 48. So how you do the subnetting? If you have a 32 and you want to make 48, you need to find out. So first of all, there are a lot of subnetting websites. You can just put your address there. They should just calculate it. You don't need to go through this process. But just to show you how it happens. I think I have slides for that. So let's say I was here. 16 and 16, 32, that was my parent subnet, main subnet. I want to make 48 subnets from the main prefix. So from here to 48, I have 16 bits, binary bits, or 4 nibble bit, or hexadecimal digit, whatever. So if I expand it, it will look like this, right? And if I want to create subnet, I can just change this number in a binary format. So I can this will be my first prefix subnet, then 1 will be second, and then 1011, 100, 101, 110, blah 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 blah, all the way to 1111, 161, right? That will be my 65,000 subnet. Can be created, right? So this will eventually have to be written like this. So if I convert it again, it will look like this. If I convert this on here, so 0, 0, 0, and this one is 1. This one is 2, so 0, 0, 0, 2. So you see there is a sequence, right? And then finally F, 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 F. Right? That will be your 65,536 number. Now can you do the subnetting of this prefix to 36. Instead, you do that. Let me do it because I need to save some time. But you need to understand, okay? So I have 2406 6400:/32. Okay? Now I want 36. So if I expand, I'll get 0000. Hold on. This number same, okay, here?
Yeah.
This is 32. This is 32. And then I'm just, because I need to do subnetting from right side, I need to expand it a little bit. So I can write it something like this. Is it same?
Yes.
2406:6400:0000 double content is the same meaning as this, isn't it?
Sama persis.
Same.
Ya,
Oh,
sama.
no.
Diperpanjang.
Now I have to find out my boundary. So this is 36. This is 40.
40,
This is 44.
40.
Ada yang tahu
This is
kenapa
40.
kegaduhan di situ?
Karena 4 bit per angkanya ada 4 bit.
Nibbles.
So I want to do subnetting of 36. So I cannot do anything here. I only need to focus on this. Like the previous example, I was doing subnetting 48, so I was focusing on everything here. Right? It's the same as IPv4 subnetting. Now this is a hexadecimal number, right? It's not binary. I can actually expand it to binary numbers and then do my mathematics like 0001, 0010, 1011, blah blah, and then finally 1111. And then fold it back to one hexadecimal number. It is 4 digits, right? How many subnets I can create? 16 because 4 digits. So I will start with 0, 1, 2, 3, 4, and finally F. So that will be just easy subnetting. Okay? Make sense?
Makes sense.
Now, if we do something different, if we do 35 as my limit, I have to do subnetting here in these 3 bits. Because 33, 34, 35, 36, but I don't want 36, I want 35. That's in the middle of the nibble bit, and that's going to be a little bit complicated. So I have to subnet something like this. So I can get 8 number now. Because I lost 1. In binary, if you lose 1 bit, that's half lost. Because 1 bit can be 0 and 1, and that can create double the number. So now, remember, if I fold it back, I have to have the 4th number as well. But that's the last number, I cannot change it, it will be just 0. So now there's going to be 0, there's going to be 2, there's going to be 4, and that's you are missing. The intermediary numbers are missing. And that's how your number becomes. And it's a complicated one. So why I did it, I wanted to give you a message, subnet in the nibble bit boundary, not in the middle of the nibble bit. So subnet 32, 36, 40, not 39, not 38, because it's not problem. It's not a invalid solution. It's valid. It's possible. No one is going to complain. Computer is not going to upset this time. But it's difficult to maintain.
Yeah.
It's a challenging way of subnetting.
Try to difficult yourself.
Yeah, I think. Sometimes you can say my life is already lost. Why bother? Let's do like 39. What's the problem? Because I already had everything gone. Why bother with this? Yeah, so you can keep your life easy, or if you feel better, you can make it difficult as well. So yeah, that's the summary how we did it. And now let's do some planning. I have a /32. This is this is a APNIC big block, a /12. From there, APNIC gives 32, 48, whatever, whoever needs one. So let's say usually I get a /32 as an ISP from APNIC or from IDNIC, and then I want to give some to my customers. But before that, remember, the minimum subnet you can announce to internet in IPv4 is /24, right? In IPv4. the IPv6 is /48. So you can, if your customer wants to do BGP, you need to at least give them a /48. And don't think that why I'm going to give you this a huge valuable thing in my locker, and I cannot give you there like a big /48. You have so many addresses, so be generous when you give. Okay, you.
Ya, relakan saja.
Yeah, sometimes. So how I give the example, you have a very big land, okay? Previously you have been in an apartment, it was IPv4, very tiny, you put everything in the same room, and now suddenly you give a very big land. You are still, if you are still thinking the same way that I can build a small house at the corner, and rest of the lands can be for future. That's a wrong idea. You need to do the master plan first. Doesn't matter whether using the land today or tomorrow, you can make a good plan first and then build whatever needed now and expand it later. But if you just build something at the corner and tomorrow you have a good idea and then you have to break this one and rebuild that one, which is very difficult in network concept. You are breaking the internet for some time. So, think about your customers. When you give them a bigger one. Okay? Be generous when you give because you have so many addresses. It's not that valuable, not that important. Okay, now when you announce to internet, do not announce /48. Try to minimize the announcement. Announce aggregate prefix. If you have a 32, you have 65,000 plus 48. If you want to announce 48, you have to make that much announcement to cover the whole range. Instead, try to minimize the number because the routing table is going to be very, very big if you do that. And if everybody does that, that's really crazy. So no need to do that. Okay, shift in thought. Previously, we were thinking how many hosts in IPv4. Okay, how many hosts? Okay, so 14. Okay, take a /27 or 28. But tomorrow you have one more. Okay, now a problem. You need a bigger one. But in IPv6, don't think about number. You just ask how many LAN you have. Just take /64 from my subnet LAN. That's it. It doesn't matter. So now, another concept is whether you should give address sequentially from the beginning and start giving, or you should make a split allocation. Now the idea is, the recommendation is, instead of giving continuously, give from the split allocation. Because sometimes we have multiple upstream provider, we announce some prefix here, some prefix there, to balance the load, right? Load balancing. If I have all customers here, if I split from half and give and announce half here and half here, this half doesn't have any traffic. Because no one is attracting traffic, no one is using their IPs. Everybody will go to the first one. Now you have to split somewhere here if you want to make a balance. But instead, if you give first customer from here, second customer from next half, third customer from here, fourth customer from here, fifth, then you just split into half. Some traffic will be there, some traffic. If you have more than 2 upstream provider, you can even split it into 4. So give the first customer from here, second here, third here, fourth here, fifth here, sixth here, 7, 8. Do your own planning. It's not a hard and fast rule. You can customize it based on your need. Any question about it? This is based on traffic engineering. If you don't need it, don't bother. But I think eventually today, if you don't need it, tomorrow maybe. So who is gonna take the risk? So let's think about this is a typical ISP. I have my own infrastructure, and I have my different type of customer. There are enterprise customers and there are both broadband users and home users. Now let's see, I'm splitting into 4, and I'm gonna do this planning now. So /32, if you split half, so /33 and next /33. This /33 will be 8,000 because whole is 16, and if you split in the middle, it's gonna be 8. So, and if you split the first /33, you will get 234. If you split the second 33, you're gonna have 234. So 0, 4, 8, 12 is C. Okay? That's how you do this splitting. Now let's take a look at my infrastructure first, then I'll talk about customers. And that's what you need to do when you go back. You need to bring the valuable thing out of the locker, and then you need to do a master plan. So for the infra, in network, infrastructure is my own network. It's not customer, my own network. And I can dedicate a /40. Again, all the subnetting is done with the nibble bit, divisible by 4, something like this. So I can dedicate 1/40 or /48 depending on how you want. You can do that, no problem. And then you can carry infrastructure IP with IGP, means your OSPF or ISIS or any other IGP protocol. You need to carry them in IGP. And this is basically 2 address types. One is point-to-point, and another one is loopback. So your infrastructure IP basically indicates 2 types of IPs. Loopback address of your routers, and point-to-point IP of your backbone, because all your routers are yours, and you have connectivity between the routers. That's called backbone connectivity. And those IPs will be your infrastructure IP, and you will configure OSPF for them. And in the lab, we'll practice it as well, right? Did you get the point? No other routes should not be in the OSPF or ISIS. If you need, you can redistribute, of course. Customer route can be, but that's not a good idea. If you can avoid it, avoid it. I'll talk later if you have question why. I'll talk this later because this is not important at the moment. So, first subnet, /40. I'm just taking it away. I'm just keeping it for myself. The rest of that address, this big blue line for my customers. Okay? And this /40, I'm taking for infra. Now let's say, what could be my infra? There could be other infra, but remember 2 is very important, loopback and point-to-point, and they will be in IGP. There will be other infra, I'm going to talk about a little bit in a while, but let's see. First, my loopback addresses. Loopback is 1 IP, right? For everybody, everyone has only 1 IP as loopback. So I can take some subnet for loopback, and then comes the point-to-point as my infra as well. Now there are more infra. My internal servers. I can have a billing server, I can have internal DHCP server, internal DNS, things like that. I can have external servers. My external facing servers, like mail server, like DNS, the public DNS that I have. And my customer login server, the authentication server, and things like that. Now, take a look at loopback. I have reserved a /40 for my infra. From there, I can take 148 or a 60 or a 64, whichever makes sense. Again, if you are thinking that's a waste, I don't have that many devices, I only need 1 or maybe 10 IPs or 100 IPs. Just change your thought. Don't think that you are wasting the address, okay? Just better management. Better management is the target here. Not because I have so many, I need to do better management. So /40 or 60 or 64, whatever suits you, and then configure. This is in my plan, and this is in the device. When you configure /128, but keep in your plan as a big subnet. Oh, sorry. Yeah, now comes, so out of /40, I'm reserving a 48, but like I mentioned, you can go for 64, 60, whatever suits you. I'm keeping a bigger subnet, /40 for my loopbacks. When I use them, let's say I have only 4 devices, but I just reserve this /48. If you think like it's too much, you can reduce the size. So first one, I'm using 1, second one, 2, 3, 4. So I have a big plan. Out of /40, I have all the IPs, 128, 128, 128, all the IPs, and I'm using. Look, I didn't use the first one. This is a valid address, but I didn't use. Why? Because sometimes we number the router with 1, 2, 3, and in IPv4, and I want to use the similar pattern in IPv6. But IPv6 starts with a 0. 0 is a valid IP in IPv6. But then it breaks the pattern. So I said, okay, first IP don't need it, not need to use. Just use 1, 2, 3, 4. It's meaningful to me. That's why. Here comes the point-to-point links. You assign a /64, but use a /27. You assign a 64 in the plan, because every LAN is a /64 in IPv6. That's a recommendation. So I'm taking the second 48, because with the 40, how many 48 I can create? With the 40, how many 48 I can create? With the 40, I can go up to 8 bits. So with 8 bits, how many subnet you can create? 256. That's your IPv4. Very easy. /24 means 256 IPs. So I can have 256/48. So I'm taking the first one for loopback, second one for point-to-point. And with that 48, I'm gonna create all the 64s, and one 64 for one link, second 64 for another link, third 64. How many 64 I can create? 65,000. And that's enough for my lifetime. My kids and grandkids can run the network, even if they serve the multi-continental network, they can do that. So again, first one I'm not using. You can use. That's a valid one. But I'm just saying that it's meaningful if I have 1, 2, 3. So these links, there is a link missing. Here is a link, 1. This one is probably 2. This one is 3 and 4, things like that. But when I configure it, look at that. I'm configuring a /127. Now you can ask why I'm wasting the rest of the 127 here. Because I'm following the recommendation done by the RFCs, done by the engineers. I have so many addresses, I don't want to reuse in a different LAN. I don't want to same subnet. I want a different subnet. Then internal subnet.
How about 120?
Okay, that's a good question. Tomorrow I'm going to cover a little bit about it, and today as well. We have a combination of two things. Mikrotik or microtik.
Yeah.
Is Indonesia says microtik or
Mikrotik.
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 You are right. I think rest of the world, many people say microtik, which is wrong. Because microtik itself, the company itself, and pronounce it as mikrotik. Mikrotik. Because it's an Eastern European accent, right? Mikrotik. Something like this. So mikrotik does not. Mikrotik is not very friendly when you configure a /127 and run OSPF. It's gonna break. It's gonna break. So if you have microtik or mikrotik, you just use a /126. Don't use the first IP, don't use the last IP, use 1 and 2. But any other vendor, they support 127 on OSPF or ISIS in IGP. So mikrotik is fine if you do point-to-point links, do BGP and things like that. When you run OSPF, and that's going to upset the mikrotik router. So if you have mikrotik, you take a /126, forget the first one and the last one, like the IPv4 one concept. We just implemented that. But we have in our lab, we have a combination, so you understand why we are using it. Internal servers, I'm not going to cover. You may have some external server, internal server. You can reserve some subnet for them. Remember again, one LAN, 164. You don't need to count how many servers you have. Very close to the break time. Next up is like internal servers, external servers. Take a small piece from there because I don't have so many internal server LAN, so many external server LAN, but you can choose another spot because the rest of the things are going to be empty now. If you want, you can take 48 as well for them. Don't worry. Now comes the two types of customers very quickly before the break. Enterprise customers, they are bigger customers. Banks, universities, offices, who else? Similar type, but a little bit bigger, not the home users, okay? Now these enterprise customers need a different treatment, a different support than the home users. They should be assigned with at least 1/48, because they are not your only customer. They can have another upstream provider for redundancy, and they want to use that prefix to announce with that network as well. Some people say this is not legal, but in many parts of the world it is okay, because I'm maintaining with my source. The connectivity is still there. They assign me a prefix with a who is entry, so I'm legitimately I'm legitimate, or I'm valid to use that address to announce in BGP globally via other providers, because I'm still maintaining their link. If I don't maintain, then I don't have any right to use it. So there are doubts or debates, but no concern about those points. Just keep your mindset that I'll support my enterprise customers with bigger blocks, and that's at least a /48. Doesn't matter whether they're using it in a different upstream provider or something like that. First, break your network into region, and this region is not bigger region. If you are running a small ISP, your area, you can split it into a couple of parts, and that's the region. If you are running a big network, you can have bigger area for region. So I'm splitting it into multiple regions, and each of the regions, I'm going to give a /40 for each of the region. Not the customers. This is customer comes from the region, not it. Why I'm saying first the region? Because if I continue for region on, if I continue assignment from this 40, I can just advertise one prefix to my backbone from the region, and all the customers covered. I don't need individual prefixes of customers to be in my routing table. One aggregate prefix will cover everybody, just minimizing my routing table. That's why I first allocate with the master plan. Remember I told you, you have given a big land, you need to make your master plan first before building the infrastructure. Okay? So first region given from here. Now I have the traffic engineering as well in my mind. So the second region will here or here or here, not continuous. Because if I do continuous assignment, all my traffic will go to one subnet, not the other subnet. Other subnets will be empty, and my traffic engineering will not work. So region 1, region 2, region 3, something like this. And then if I have more regions, I'll go to the next one here. Second maybe here, second, third. You can actually expand it because you have so many /40s. Now for the enterprise customers, /40 at least. For the home users, give them, okay, so this is not about home users, but some ISPs give smaller subnet to enterprise customers. This is not recommended, okay? /64, not at all recommended. Because they only have one subnet. They cannot do now VLAN or any other subnetting by themselves, because office can have different subnets, staff, like admin, finance. You have seen, like, university can have different departments. So no way you can give them a /40, 64. So let's say this is a from this region, I'm gonna give my enterprise customers. So for every region, I'm gonna keep a /40. For every region, I'm gonna keep a /40, and from that 40, I'm gonna give /48 to every enterprise customers of that region. I don't need to advertise these 48s. I'll just announce this one 40. They will be covered.
Aggregate routing.
Yeah. Thank you. So let's say I have 3 customers, enterprise customer in that region. I have more customers, but they're on different regions. So I'll give them address from that region. Okay, I'm not gonna reuse, or I'm not gonna mix and match because I have so many address remaining. So I'll make a big plan for that. Now how about customers? The enterprise customers need a point-to-point address. Not only their LAN, they also need a point-to-point address with you, right? So that's called WAN link. You can take first /48. Remember, this one is not allocated to anybody. This will be a /48. I'll split it into 64. I'll give 164 to one customers, each customers. But I'll tell them, I'm gonna give you a /126 or a /126. I'm not gonna tell them that I reserved a 64 for them. Because if I say 64, they might configure 64, but I'm configuring a /127 or 128 depending on whether I'm using MikroTik or not, okay? Or depending on they use MikroTik or not. Usually for the customers, you don't know whether they're going to replace it tomorrow with a MikroTik or not, but no problem. In IPv6, you reserve them a /64. If they change the router, you'll reconfigure with, because it's not used for anybody else. You can make it 126 or 127 depending on what router they have. So for IPv6, that's a good way of dealing with it. So this is the plan. Again, the first one is reserved not for any specific customer, but for anybody who is going to join. And I have 65,000 possible /64 point-to-point links for that region, and that's more than enough. I will not have 65,000 enterprise customer in one region. And if I have, I'll give them another 40. Remember, I just give one, but I have more 40s here in the blue line. So never, I think it's like endless. I'm not so sure when it's going to end, but so for the one links, you use the 64, but configure it as 127 or 128. Next comes the enterprise customer. This is home users. And home users, you can again give each home users a /48 for each region. So again, this one was enterprise customers. This one is now for the broadband customers. Okay. For that /40, I can create several 48. Each of the 48 will go to the BDAS, okay, the NAS or BDAS, whatever you are using. From that 40, whoever in this BDAS will get at least a /60, not 64. 64 is valid, no problem. But there is a there's a good way, or a better way, or a good best way, something like this. So the better way would be if you give them 64, but the best would be if you give them a little bit more. Why? Because there might be engineer living in that house. He might be very, very bad engineer to configure VLAN in his house. And now he needs multiple subnets. And you are an ISP, you should give them the opportunity. It's not IPv4. And he can ask you why you are treating me as a V4 customer. You have so many addresses. Why you are so miser, or why you are so he can say something like this: you are even bad than me as an engineer. So don't take the blame, okay? Yeah. So give them at least a /60 so that they can have 16 subnet they can create within their house. Nowadays people have a smart house. They have their child network different, blocking some content. But for them, they don't block anything. Yeah, so give them some opportunity. Break. Okay. Let's see. I think I'm very close to finishing. So give me another minute. It's very, very close to finishing. So there will be another 1 or 2 slides. So for the customers, one is called PD, one is called WAN IP. If I'm a home user, my home router should have a public IP towards my upstream provider, and I should have public IPv6 for my home devices. That's called prefix delegation. I will dial, they will give me 2 IPs. One for my WAN, one for my LAN. Okay? So that's called PD or prefix delegation. We'll configure in the labs, don't worry. So these are for the WAN. The first subnet is for WAN, and all the second subnets are for the BDAS. That's pretty much it. Data center, just think about an ISP itself. If you have a data center, give them a big subnet and then do again the same plan, infrastructure, IP, point-to-point, and things like that. Treat them as a different ISP. And then load balancing, announce them multiple subnets to load balance. I think from here 32 or multiple 34 or multiple 33, something like this. Routing, I told you IGP will carry the point-to-point and loopback, and the customer traffic will carry by IGP. And that's it. I will stop probably here because the enterprise customer not needed to be covered. But you can see the slides, you will understand. Thanks so much. Let's go. We are not taking any question at the moment, but we can discuss later once we come back. Okay?
Thank you.
Okay. Thank you.